Time, we think, is steady. A second here is a second there. An hour on Earth is an hour on Mars. Our clocks tick in sync with the universe itself. But this, like so many things in nature, is only an illusion, one that holds up just long enough for us to trust it. Because the truth is this: time can stretch, not in imagination, not in metaphor, in motion. This is what Einstein revealed in the early 20th century, not as speculation, but as a consequence of the speed of light being constant. If light won't change speed for any observer, then time must change instead. There's no other way to preserve the order of cause and effect. This bending of time is called time dilation, and it is not a quirk of thought experiments. It is real. It has been measured. It happens every moment, whether we notice it or not. When you move quickly, very quickly, your experience of time changes. Your watch ticks a bit more slowly than the one you left behind. Your heartbeat, your breath, your entire timeline lags ever so slightly behind. And the effect is not just visible in laboratories. Muons, tiny particles born in the upper atmosphere, should decay long before they reach the ground. They don't, because from our point of view, their clocks are running slow. They live longer because they are moving fast. Satellites in orbit, like those powering GPS, experience time differently than we do on Earth. Their clocks drift slowly but measurably, unless we correct for it. Time dilation isn't a theory for deep space. It's a fact of your morning commute. But why don't we feel it? Because in daily life, the speeds we travel are infinitesimal compared to light. The dilation is tiny, trillions of times smaller than our senses could register. When you ride a train or an airplane, your clock does tick more slowly than one at rest. But only by billionths of a second. Not enough to age differently. Not enough to change your life. It's just enough to prove that time is not what we thought. This is the part that's hardest to accept. Our minds evolved under gravity, under friction, under slowness. We assume that time is universal, that every moment happens simultaneously for everyone. But that's only because we're all moving slowly together. We're synchronized, not because the universe made us that way, but because the distortion is too small to notice. The faster you go, the more that illusion breaks. Approach light speed, and things change. The minutes you experience may become hours, or days for someone who stays behind. You feel normal, but the world outside races ahead. And the reason isn't magic. It's consistency. The universe is trying to hold itself together, to preserve causality while still allowing motion. And so, as you accelerate, it stretches your time to keep you from violating that limit. It's not by punishing you, not by stopping you, but by giving you an alternative. Travel slower through time. The closer you move toward the speed of light, the stranger time becomes. This is not a figure of speech. It's not abstraction. It's what the equations demand. It's what the universe delivers. Imagine a spacecraft not just moving fast, but close to light speed. 90%. 95%. 99.999%. From the traveler's point of view, everything feels normal. Their thoughts unfold at a natural pace. Their heart beats steadily. Their seconds arrive one after another, just as they always have. But outside that ship, on Earth, perhaps the clocks are racing. To an observer watching from afar, time aboard the ship slows to a crawl. A day on board might be a week back home, or a year, or a lifetime. This is not a trick of measurement. It's not a distortion caused by motion. It is the reality of motion. The faster you go, the less you age, relative to others. This leads to one of the most famous thought experiments in physics, the twin paradox. Two twins, identical in every way. One stays on Earth, the other boards a ship and flies close to the speed of light. When they reunite, they are no longer the same age. The traveler has experienced fewer years, fewer thoughts, fewer moments. Their body is younger, their memories are shorter, and yet, for them, nothing felt unusual. They were never aware of time stretching. It did not feel slow. They felt unchanged, because time dilation is not something you experience. It is something others notice when they compare. You could travel to a distant star, 100 light-years away, and return, while only a few years passed for you, and a century passed for everyone else. You would return to a different Earth, to the future, to a world that continued in your absence. And yet, you'd have made no machine, no paradox, no loop, just a journey protected by the laws of physics. This is the hidden gift of time dilation. It is not a barrier, it's a pathway to high-speed travel, to the edge of time, without ever breaking the speed of light. And it raises a quiet, haunting question. If someone leaves and they return far in the future, did they travel through time? Not in the science fiction sense, not by breaking rules, but by obeying them so completely that time itself had no choice but to yield. The universe does not allow faster-than-light travel. It's not a rule you can break with enough force. It's a law that holds up the structure of time itself. But instead of slamming the door shut, the cosmos does something more elegant. It bends. You may not outrun a beam of light, but you can stretch the time you experience while trying. The faster you move, the more space and time yield around you. And the closer you get to the limit, the slower your clock ticks for everyone else. This is not a penalty. It's the cost of preserving causality. The universe would rather slow your time than allow you to reverse it. It would rather warp reality gently than let it fracture completely. That's what time dilation is. It is nature's compromise. Quiet warning. You can go fast, but you must leave time behind. And in that trade, there is opportunity. Because while time dilation limits speed, it also opens a door to something extraordinary. Relativistic travel. If you could build a ship that traveled near light speed, you wouldn't just move through space, you'd leap through time. You could reach distant stars in a human lifetime, while centuries pass for those back home. This isn't fantasy, it's physics. It's a kind of time travel without paradox, not because you violate causality, but because you cling to it so closely that time bends around your path. The faster you go, the slower you age. Your journey becomes a compression, shortcut not across distance, but across experience. And that makes every interstellar dream more poignant. Because the price of touching distant suns may not be death or danger. It may be the quiet loneliness of returning to a world that has moved on without you. Time dilation is not just a quirk of motion. It is a reminder that every speed has a cost. Every journey alters more than location. It alters the rhythm of life itself. It all begins with a simple truth. The speed of light is untouchable. But if you reach for it, time will reach back.